Okay, hey guys, my name is Patan, and here I'm going to explain to you how to do questions 14 on chapter 5, which is this problem. So here we're going to determine the reactions at the roller supports, which as you can see here we have two roller supports, which is roller A and roller B, and we're going to determine the reactions on both of those supports. And then this beam is subjected into a uniform force of 800 newtons per meter on all parts of the beam on that part. And also here we have the information of the length of certain parts, which is from up down to up there to down here is 3 meters. And then from the distance from the edge of the beam to the A roller is 1 meter, and from roller A to roller B is 3 meters. So we're going to move on to analyze the FBD first. So as you can see here, we have the beam and we have the resultant one, which is the resultant of the 800 Newton per meter, which will occur at the metric center of the beam, which is located at the middle part of the beam. So it will be located here at the middle of the beam, and then other than this resultant, we also have the resultant of support A, which we denote as AY, and also reactions from the B roller or the B support, which is we have Bx on the x-axis and By on the y-axis. So yeah, and then we're going to determine what is the length of the beam first from by this equation here using the Pythagoras theorem, which we can have this part, which is 3 meters pangkat 2, and then we multiply it with 4 and di pangkat 2. And then we will find the length of this beam to be the root of 25, which the length mean it will be 5 meters. Okay, so we know that the beam length is 5 meters. We're going to find the resultant of the 800 newtons per meter, which will be equal to the area of this rectangle here, which will be 800 newtons per meter multiplied by the length of the beam, which is 5 meters. Okay, and then if we calculate this equation, we will find that this resultant here is equal to 4,000 newtons. Okay, so now we know the value of this resultant. Next we're going to find out what is the value of the resultants of AY. So to do this, we need to analyze. We need to know first that this beam is equilibrium. Means that all moments, the total sigma of moments applied on this beam is equal to 0. So we can predict that the sigma moment, which we will analyze it from the B here, from the B support. So we put it B here is to be 0 because it's not moving anywhere, not up, not clockwise or not anti-clockwise. It just stays there. So yeah, to do this, we can use the torsion method, the torsion approach, which we can find that the reaction multiplied by the perpendicular length will be equal with the AY resultant multiplied by the perpendicular length. So first we have the resultant first, which is 4,000 newtons, or we can write the notation first, which is the resultant multiplied by the perpendicular length, which is 2.5 meters, and 2.5 meters is because of 5 meters divided by 2, because it's in the middle. So yeah, and then we is equal. Okay, it is equal with AY, the resultant of AY multiplied by its perpendicular length, which is 3 meters. Okay, so here we have the equation, and we are going to insert the values, which is 4,000 multiplied by 2.5 equals to the resultant of AY multiplied by 3 meters. Okay, so here we will find out that AY will be equal to 3,333.33 newtons. Okay, so we have the resultants of AY and we have the resultant of the B support, which I can see now. Okay, so for the B part, we can analyze it from the x and y axis that I've drawn here. So here on the x-axis, we can find that the resultant is also acting on the x-axis, which is denoted by resultant sinus of theta, and then on the y-axis, its resultant cosinus of multiplied by the cosinus of theta.
and then we're going to the theta later on, but we can start from writing that sigma, the total of force applied on axis x is 0 because it's an equilibrium again. So as you can see, the force acting on the x-axis is dx, and also resultant multiplied by sinus of theta. So we can write that dx is equal to r sinus of theta. And yeah, so for bx, bx is a value that we want to find, and for the r of sinus of theta, we can insert the values, which is 4,000 newtons sinus of theta. Okay, here, based from the trigonometric triangle that we've created before, we can determine what is the sinus of each theta. So for sinus of each theta, we have this triangle here, 3, 4, and 5. Sinus will be 3 divided by 5, and cosinus will be 4 divided by 5. So I'm going to put it. Okay, yeah, so we can insert these values up into this equation there, which sinus of theta is 3 divided by 5. So from this equation here, we can find out that dx, or the forces resultant of B on the axis of x, is equal to 2,400 newtons. So we found 2 out of 3 of the resultants here. This and this. Okay. Now we need to find one more resultant, which is the B on the y-axis. No, I'm good. Yeah. Okay. By. Here we can determine it from the all forces applied on axis y, which is also 0 since it's an equilibrium. And we can write here that all forces on axis y is equals to 0. So yeah. So the forces on axis y we have r multiplied by cosinus of theta, which is this part up there, and it's in a opposite direction of the by part of the by thing. So here we can just put that all forces on the y-axis equals to, let's say that the upper part is the positive, so ay subtracted by by subtracted by r cosinus of theta. So yeah, let's put in the values. Ay is 333.33 newtons, subtracted by by, which is the value we are going to search for, subtracted by the resultant, which is 4,000 multiplied by cosinus of theta. So here we can find out that by is equal to 3,233.33, and subtracted by 4,000 multiplied by cos theta, which is 4 out of 5. Yeah, and then from this you just need to calculate it, and you'll find out that by is equal to 133.33 newtons. Okay, so we have all the reactions on all two supports. So on the support A, we have this reaction, which is 3,333 newtons, 0.33 newtons on the y-axis, which is positive headed, and also we have the Bx reaction, which works on the x-axis on the B support, which is 2,400 newtons on the positive direction. And then we have the by. We have the by. Yeah, we have the by resultant, which is 133.33 newtons. on the axis of y. So I think that's all I can say today. I hope it helps and thank you guys.